We're Expedition 30 on the International Space Station, and we're going to demonstrate a few of the technical details about orbital trajectories around Earth. So here we have our blow-up version of Earth, and we're going to show what the trajectory a space station is like around Earth. So this strapping material, which I cut off of one of our food containers, this represents the orbital trajectory that space station takes when it goes around Earth. And it doesn't go around in a circle. We all think that, wow, it's going in a circle. It doesn't go in a circle. It goes in an ellipse, which is close to a circle, but not quite a circle. And we're about 300 nautical miles above the surface of the Earth when we orbit. So we're not really that far away from the surface of Earth considering its diameter. Here's our orbit, and one thing about our orbit, it's inclined to the axis of the Earth. And so the uppermost part of our orbit is 51.6 degrees north latitude, while the southernmost part of our orbit is 51.6 degrees south latitude. It happens to cross the equator at 51.6 degrees. So this is referred to as orbital inclination, and this is the inclination that the space station is in. So let's start off with space station now at the lowest part of our orbit. There we go. Space station is at the lowest part of our orbit. It's at minus 51.6 degrees or 51.6 degrees south latitude. And it's going to move around the surface of Earth. And it's going to come moving from its perspective in an ellipse, which gives it a straight trajectory, and it will pass the equator somewhere over South America. And then it continues on and it reaches the northern part of its trajectory over Europe. And in this case, it's right over the Netherlands, where Andre Kuiper's from. And then it continues on its trajectory and it starts to go to southern latitudes now, but we're still moving in a straight line. We're moving down here. We're at the equator again, somewhere over Asia. And then we come around and we are back at the southernmost part of our orbit over the South Pacific again. And if we plot these points on an atlas, even though we're moving in a straight line over the surface of Earth, when we plot them on an atlas, it makes a curve. Let's see that. Let's look now at the projection of the space station orbit on an atlas. So remember, we started off in the middle of the Pacific Ocean at the southernmost part of our orbit. So that's down here. And we started to go across the Pacific Ocean. There we go across the Pacific Ocean, and we crossed the equator right in the middle of South America. And then we go across the Atlantic Ocean like so. And remember, we're traveling in a straight line because we're in orbit and we're making what looks like a circle, but it's really an ellipse around the Earth. And then we peak out at the northernmost part of our orbit at 51.6 degrees north latitude, which puts us right over Europe. And after that, we're starting to go down again in latitude. And we go over the Middle East. We go over India. We hit the equator somewhere over Asia. And then we end up at the southern part of our orbit again, out in the middle of the Pacific. So, with my little Lego satellite version of the space station. We start off here, we go up, and then we go back down, like that. So we make a curvy trajectory when we plot it on an atlas. Let's look at this again on the globe. It's really moving in a straight path. We're crew of Expedition 30. I'm Don Pettit, Dan Burbank, Andre Kuipers, and we just finished giving a little demonstration on orbital paths as we circle Earth in the International Space Station, and how, from our perspective, we're going in a straight line, but when you plot that on a map of Earth, it defines a curve.